Oh yeah, oh yeah. All right. What's up, everybody? This is Ryan, and you are watching episode 52 of my live stream Q&A. So, I had a pretty busy weekend. To give you just like a brief idea before we get into the code stuff, I went over to my parents' place. They basically live on a different island than I do, to kind of have a chill weekend, and we ended up doing a big concrete pour. So I am physically pretty sore and exhausted from that. But nonetheless, here I am, and at least I'm not underslept for a change. I'll take being just physically tired over being brutally sleep deprived. Anyways, things are good though. So yeah, let's just kind of jump in here. So, if you would like to support what I'm doing here to support the WiseAss community, then please do me a favor and consider following WiseAss on Google+, Facebook, Twitter, and consider joining our Slack channel. Link in the description box down below. Consider subscribing on YouTube if you haven't already, and hit the like button down below if you end up learning something today. And lastly, this channel is partly supported by donations from wonderful people such as yourself. If you can't afford to donate, then that's totally fine. I've been there, I know what that's like. But if my content helped you, then please do consider donating what you've paid for similar content on Udemy or something like that. I often get the feedback that my free content is better than a lot of Udemy courses, which makes me giggle quite a bit. That's pretty hilarious. So, and also kind of pathetic for the Udemy courses. But anyways, yeah, that's basically my commercial for today. So I don't have a huge number of announcements. So number one, I know I probably first made this announcement sometime at the start of this year, but I am going to be making a new Android WTF video, which will be on fragments. So I will finally answer people's questions on fragments, because I know I've been getting a lot of questions about it. And to be honest, it's not really that complicated, but it's definitely worth taking you through a short video. So the state of that video is I have the video plan written out. I just have to record it. So I'll probably get around to doing that either today or tomorrow, and that should be up soon. There's also, so last week, as I said, I'm going to try and output about 1 to 3 videos a week in terms of like separate pre-recorded videos. For last week I managed to crank out a video on live data and RX event streams, which was actually a stream highlight, but it was good enough that I thought I would pull it out into its own video. So if you're curious about how live data works specifically, and also how event streams work in general, I ended up explaining sort of live data and by extension event streams in a very, very simple, easy way to understand, which is the gist of it is to just treat live data essentially like a tube that data travels down, rather than thinking of live data as the data you're trying to get out of your database, for example. And then also last week was a video on context for Android, the context class. So I talked about what it's for, sort of I define what context means in the English language to help you understand why that particular word is chosen. And just different things you need to be careful of, like making sure that you garbage collect context correctly, because otherwise, because it's a class that has references to like everything on the Android operating system, it's just a really bad class to have a memory leak occur. So anyways, that's it for announcements. Let's check out the chat. Holy crap, we've already got 10 people watching. All right. So, got a couple questions immediately. So I'm just looking up a term I've never heard before. Let's see here. Oh yeah. So yeah, let's just get right into it today, because this is a this is going to be a speculative question. So let's go to what was your name? Elias. All right. So the question for today, Elias asks, is it really true that the PWA will take over the Android development? Well, okay, I'll stop doing my German accent. Is it really true, or I'm paraphrasing, is it really the case that PWAs will take over Android development? So I actually had, while I was, that bit of downtime, there was me Googling what a PWA is. So I just learned that a PWA, people love to make names for things. So this is a progressive web app. So I already don't really like this name, but I do like the concept. So so the concept behind this thing, as I briefly glanced at the Wikipedia page, is something I've given a lot of thought to. So so here's a speculative point, and this is something I thought about a couple years ago, to be exact. So one of the things I realized is that unless we end up blowing ourselves up beforehand, or we create the AI singularity overlord, what is going to happen at some point is that eventually our internet connections are going to be so fast that it doesn't actually really, so this is my opinion, that it doesn't actually make sense to put most of the application on, say, a mobile device. What I mean by that is, if it is true that internet is fast enough that I could hit a button here on what is essentially just a view device, and when I say view, I mean like user interface, just user interface on here. If the internet connection is fast enough that it is an equivalent amount of time for my button press to either reach the back end of the application, or compared to if I hit a button and the back end of the application is on a server. So what I'm saying here is, what I see happening is that these things will basically just be view renderers that will just forward click events, for example, through the internet, through the browser, to a server, as opposed to forwarding it just to the back end and then having the back end make the decision about the click event. And so that is possible, in my opinion, as soon as we have internet that is fast enough to do that and it's globally available. So in that particular case, it no longer makes any sense, in my opinion, to actually have any kind of database on here or anything like that. This will basically just become a lightweight view renderer. Maybe you'll have Google Glass, maybe you'll have this thing. So that is, that's something I've thought about a while ago. I've never heard this term progressive web app before, but after reading the Wikipedia article really quickly, that appears to be what they mean. And so the basic gist of it is that if we have that internet speed, the internet bandwidth is fast enough, I'm probably saying that wrong, but whatever, then it, like I say, it will really only make sense to just have this thing as a view renderer that has a browser still. It should still have the browser, and then you'll just end up rendering everything on here. So then the next question becomes, well, what languages will we use to render the view? Now, naturally, as developers, we're going to want to find one language for multiple different kinds of devices. So there are options out there. There's React, there's whatever the new Google thing is, Flutter, and with Dart, I believe, is the language Flutter's written in. So there's different options that are popping up, and we are already seeing as developers that it's moving towards that. For example, I've chosen to dive into Kotlin, and I will actually be working with Kotlin JS very soon for web applications. And I'll see how that goes. If I don't like it, I'm probably going to switch to something else, maybe React. But I've also heard from my friends, my programmers, that React has plenty of its own issues. And to be perfectly honest, I'm a little wary of some of the approaches that I've seen in web development. There's some pretty ugly architectureless things that I've seen. So anyways, hopefully that basically answers your question. So here's the thing. Just to answer the question directly, is it true that PWAs, and my definition of a PWA is basically we have one central application that handles inputs from every device, doesn't matter, Apple, Google Glass, smartphone, whatever. All of those are basically, how can I, let me draw a little, I'll just write a little diagram. So front end on device, so we could see React front end or whatever. I'll just say Java. Well, you know what? I'll say Kotlin/JS. Don't really need to include that part there. React, Kotlin JS, Flutter, whatever. And then back end would be just one single language, for example. So I would do it in Kotlin, but you know, whatever. And that's sort of, so what I want you to imagine is, like, let's say we have, so device A, device B, device, come on, you can spell, can't you? Device C. So all of these different things are going to be talking to one single web app. So basically, I think the idea behind this PWA thing, or at least whatever I feel like talking about right now, is basically that I do think it is true that it'll take over Android development and iOS development, in the sense that as the internet gets better, it will make less and less sense to have lots of an application on the device. Whereas if you treat the device just as a view renderer, you're going to be able to basically have one single application with n number of front ends. Basically, you might have to use different languages for the front ends potentially, like maybe, I haven't actually worked with iOS much, but maybe iOS won't support Dart or something like that. I don't know, and don't quote me on that, but at least if the vast majority of the application is in one language, that's a huge bonus, as opposed to, like, we've got one application and then we have our Android backend, then we have our iOS backend, and then we have our Microsoft, well, never mind, no one codes for Microsoft anyway, so at least for mobile. But anyways, yeah, hopefully that rambly answer gave you at least some interesting things to think about. All right, what else have we got? Thank you, Marco. Marco says, and just a language advisory warning to our viewers. I do swear sometimes, and sometimes my viewers swear as well, so I'm just going to read what he said. Marco says, Udemy is shit, you are the best. Well, I don't quite think I'm the best yet, but I will absolutely take your compliment, and I agree that Udemy is generally shit, and thank you, Marco. Okay, that's a good general conceptual question I can answer. And I'm sorry, I really have no idea how to properly pronounce your name. Nalein would be German, but I don't think that's a German name. Naleen, hopefully that's correct. So Naleen asks, why do we use Dagger? Naleen's never understood the dependency injection stuff. A simple example would probably help. So this is a great question, and I'm happy to tell you, Naleen, sorry, that so in principle, dependency injection, I'm not even talking about Dagger 2 yet. Let's just take Dagger 2 and just put it off to the side, because that's going to confuse the hell out of you. It confused the hell out of me. What is dependency injection? So, in really simple terms, this is how I define it. So let's say applied dependency injection. So this basically means if you are doing it, applied dependency injection can be achieved by not having a component, and again, don't even think about Dagger 2 components. I'm just saying part of your app. Let's actually even just simplify it. By not having, actually no, I will say component, yeah. By not having a component of your application, sorry, I'm already correcting myself. Dependency injection can be achieved by not having a component of your application build its own dependencies. So let's just iron this out really quickly. What do we mean by dependencies? Most people probably know, but I'll just kind of talk about this. So really simply, so this project is Kotlin MVP Calculator, and a link down in the description box below. I would suggest it to you, Naleen, because there is an example of a handwritten dependency injection implementation, and I'll show you that in a moment. So this right here is DI, is dependency injection. What's this? So my calculator presenter, which I want you to think of as some component, which has to talk to subcomponents. This component, calculator presenter, has these dependencies. It requires a view model, and something which I'll call a use case, but we don't really need to get into that. But it needs these dependencies. So this is the really key point here. So these are the dependencies of some component. If I go to my fragment, I don't think it really has too many dependencies. Let's see here. We have the presenter, of course. And when this is the same idea. When we create this fragment, when we create a new instance of this fragment, I actually pass in an injector. We'll talk about that in a minute. And it gives the fragment a presenter. So again, this is applied dependency injection. So what am I really showing you here? I'm just saying, so we have this object, and what it does is instead of having the object itself build its own dependencies, we have some other part of the app build the dependencies for the object, and then it feeds them, it injects them. I don't like the name dependency injection. It's this big, scary name for a really concept. Yes, I understand what they mean by injection, but why are we calling it injection? Like, I could think of so many better ways to talk about it that doesn't scare the hell out of people. So anyways, the point being, this is dependency injection right here. Constructor arguments, that's dependency injection. When you call something's constructor and you give it the things it needs, when I create my presenter and I give it what it needs, I is in some other part of the app, that is dependency injection. All I would have to do, and this would be impossible, but I'm just going to show you for example, this would not be dependency injection if I said this thing here equals, I can't create it, but just for example, let's just pretend there's some magical method, view.getInstance. So why would this not be dependency injection right here? That is because, and this is the same in Java if you're a Java developer, that's because now the object, the component, is responsible for building one of its dependencies. That is not dependency injection. That is the opposite of dependency injection. So that is the most important point right off the bat. Dependency injection is super simple. It's just giving an object the things it needs instead of the object itself building what it needs. So let's talk about what a basic dependency injection implementation looks like. So if I refer back to the question, so why do we use Dagger? And sort of what does Dagger do and how does all this stuff work? Well, here's the thing. So I'm going to assume you're a beginner or junior developer, somewhere around there. So my suggestion right off the bat, when you're learning Dagger, it's very complicated. It's very complicated for a beginner. It's easily one of the most complicated tools I've ever had to work with. And the reason why is that how you set it up changes drastically depending on how your application is set up. Now, I still suggest you learn it, but let's look at what Dagger 2 does for you. So, Dagger 2 generates the code you need in order to apply dependency injection in a very ingenious but complex way. So that's what Dagger 2 does. So what we'll look at now is how can we do this without a tool like Dagger 2? So what I'm trying to get at here is, what does Dagger 2 actually do for you when you get all your modules and your components and subcomponents and scopes and all of those things configured? What does it actually do? It generates code that looks a lot like, if I go back to Kotlin MVP Calculator and I switch to code mode because that is more useful, it looks like this injector class. Now, a lot more complicated, but this is essentially what Dagger 2 does for you. It provides a separate part of the application which is responsible for building things and providing a way to access those things. So, for example, let's go to, let's just look really quickly. What does this injector class do? So it takes in an activity as an argument, and it needs to do that because of this view model. View model providers, in order to get an instance of the view model, I need an instance of the activity. So when we want to build our presenter, let's hop into the activity wherever the hell it is. I'm going to hit Control N, and we'll type activity. So in Calculator activity, when I want to build everything, what I do, so when I want to create my fragment, I say if the fragment instance exists, so up here we just check to see if the fragment already exists. If it already exists, I don't need to build it again. If it doesn't exist, we have the Elvis operator. If this returns null, then we create a new fragment. Now, when I create this new fragment, I give this new instance method an instance of the injector, which is given an activity. So we'll hop into here. So this thing gets given its activity. What the hell was that, Android Studio? I hate it when it does that. This thing gets given its activity, and then we go into the fragment. So this is the method we called, fragment.newInstance, and then it says fragment.setPresenter. So we're calling this method down here, and we're saying setPresenter injector. So we call this method and pass, where did it go? Let me close some panels here because this is ridiculous. So we pass this thing, our injector class here, into this method, set presenter. And then, so what we do is we say presenter equals injector.provide presenter, which is this method in here. So we call this method, and then we create our presenter with a view that was passed in, with a view model that was created through passing in this activity. And then this is just like a use case down here, which works on our back end. Just think of this stuff up here as our back end. So that might seem complicated, but the end result of it is that my presenter doesn't really create the dependencies it needs. It does create this thing down here, but that's, you know, that's not like a component. This is just a, this doesn't need to be injected. So yeah, that's basically the gist of how this kind of thing works, and that's kind of what Dagger 2 does for you. What Dagger 2 does is you can like slap an annotation on here at inject, and then you configure all these different things, components and modules, and then it generates code that looks like this, basically. So what I would suggest to you, Nalin, is study that little injector there, because that is like a tiny handwritten version of what Dagger 2 does for you. Dagger 2, let me put it this way. If you're building a calculator app like this, you probably would actually want to just handwrite it like this. Whereas if you're working in like a large, complicated application, then you're going to want to probably use something like Dagger 2. Because there's a point where this code is so, there's so much of this that you end up having to write in a big application, so much of this stuff, that it's better to use a tool to make it for you. So that should hopefully answer what dependency injection is, how it kind of relates to Dagger 2. The last thing I'll talk about, which is probably one of the main things you're wondering, is why bother with all of these steps that Ryan just rambled about. So let's consider this. So, what are the benefits of having an object not build its own dependencies? So in other words, dependency injection. Why bother doing that? And I'm just going to show one last little diagram to really hammer home the whole enchilada, so to speak, the whole thing. Where is my big-ass diagram? Just really quickly, so how your app will kind of end up looking if you've applied dependency injection is you want like this DI framework, which in my little calculator application, this thing here, this injector class, is this part here of the architecture. And this thing supplies the different layers of your application with whatever they need at runtime. So that's what dependency injection is for. I actually think of it like another layer of your application, which is just responsible for building things and wiring up dependencies. So, what are the benefits? So, biggest benefit, number one. So, if you are passing in interfaces, so for example, if I go back to the application, I go to the presenter, notice how this is an interface and this is an interface. So if you pass in interfaces, if you're passing interfaces, it becomes super easy to change what's behind the interface. For example, let's say we want to work with a fake version of our data sources. This is super easy with dependency injection. So I'm now going to give you a practical example of that. So if I go back to Kotlin MVP Calculator and I open up a test class, let's go to Calculator Presenter Test. So in this particular test class, I have mock or fake versions of the view model dependency and the view dependency up here. I have fake versions of what gets passed in here. Let me just clean that up. So what that allows me to do, it looks like there's some errors in this test class because one of the things I did is the test cases, I haven't actually refactored them for coroutines. So you're seeing the test cases for the other version of this application, which is written in RxJava, and that's where that flowable thing is coming from. Whatever, we won't worry about that, but just understand that what's going on is, see here, this is dependency injection. Because the presenter doesn't build its own stuff, I can change what I give to it. So if I want to test my presenter outside of actually running the application, I can just give it mocks or fakes and run tests against how the presenter interacts with those things. So hopefully that kind of makes sense. So that's one of the biggest benefits. It gives you more control over your architecture. You can change things kind of at will. You can change what gets passed into an object, and that gives you just a whole bunch more flexibility. Number two, there's kind of lots of reasons, but number two, when working with a large application, the code necessary to build your app's parts can quickly become overwhelming. So for a smaller app, like I say, you can probably just write it by hand. For a really large app, you're probably going to want to use something like Dagger 2 because there's a diminishing return to it. Dagger 2 is difficult to set up at first, and the next 10 times you build it, it will probably be kind of confusing. That's the thing about Dagger 2. It's hellish in some ways, but once you get it working, then and you understand the basics of it, dependency injection becomes quite easy and useful. Just trying to think, are there any more benefits to it? It's good. So as a side benefit, it will reduce the complexity of your parts, your components, I'll say, because they no longer contain the logic necessary to build things. So what all I'm saying there in fancy words is we take this, where's the injector? We take this kind of code. I don't want to see any of this kind of code. In Java, we'd see a new keyword. In Kotlin, we see our initializer brackets. I don't want to see any of this kind of code in my presenter, in my activity, in my fragment. I want to pull all of that out and put it into its own layer. This is modularization, separation of concerns in action. So hopefully I've covered enough ground there. And if you have any further questions or anything you'd like me to clarify, then please feel free to follow up on that. All right, I'm just going to run a quick commercial break. If you've enjoyed the show so far, please do me a favor and hit the like button down below. Oh yeah. All right, so we've got a follow-up question. So still on the topic of dependency injection, but this is a question about specific tools. So Shashank asks, what are your thoughts about coin and coding? I don't know why my brain read that backwards. Coding and coin. So for those who don't know, coin and coding are Kotlin-based dependency injection frameworks like Dagger 2. So that's what coin and coding are. Now, I asked myself this question a while ago, and I ended up kind of deep diving into the actual difference between coin coding and Dagger 2. And one of the things I wanted to, the first question that popped into my head when I looked at coin and coding is I saw, wow, these are way simpler than Dagger 2. Now, one of the things about that is you need to ask the question, why is this simpler? Did the builders of Dagger 2 deliberately create a very complicated tool and make it unnecessarily complicated? Or are there things behind the scenes which actually make it? Are there reasons which aren't so nice that coin and coding are simpler, is what I'm trying to say. It turns out the answer is kinda yeah. How I'm going to answer this question is, so why is Dagger 2 really good? So number one, Dagger 2 is built by some of the best programmers on the planet. It was largely created by Jesse Wilson and Jake Wharton, and I very much respect both of them. They're really, really good developers, and it's currently being backed by Google. And it was an interesting case. I believe Dagger 1 was so the timeline is, first there was this tool called Juice, G-U-I-C-E, and then Juice, I think, had some, I think Juice was XML based or something, or maybe the one before it was, but so they wanted to get away from that. Then they built Dagger 1, and that was by Square with Jake Wharton and Jesse Wilson, I think. And then, so Square is another huge development company, and they actually work with Google surprisingly synergistically, considering that they keep headhunting staff from each company. It's pretty funny. Like, I think Jake Wharton started with Square and then went back to Google now, and he's working on the Kotlin team. So that's kind of funny, but anyways, I'm rambling, sorry. It's built by really good developers. Dagger 2 conforms to the, let's see if I can get this right, JSR 330 specification. I'm going to Google that to make sure I get that right. JSR 330. Yeah. Where is the... Well, whatever, I won't go, it's actually pretty dry and boring in detail, but I was correct. So GSR 330, it's basically like a specification. Just in English, JSR 330 and these things, they're standards created by bunches of developers getting together and saying, this is how we think we should do dependency injection, for example. And that's what this is here. I do not believe coin or coding conform to this at all. They'll probably use some of the same annotations, but I don't think they properly conform to that. So it's specification based, and then that leads me to the last really important point, and Marco beat me to this one. So here's the cool thing about Dagger versus coin encoding. Dagger 2 generates your DI implementation. When I say DI implementation, I mean exactly this thing. Exactly this kind of thing. The code necessary to build and wire up your architecture. It does that at compile time. It builds your DI implementation. Coin and coding use reflection. I won't go into lots of detail here, but essentially what reflection means is how it kind of works is instead of all of this being built, sort of figured out at compile time, and then everything kind of works in a, how would I even describe that? Sorry, I was in full screen mode. In a nutshell, reflection is like having some object out here outside of like the whole friggin' system supplying the dependencies. So it's like creating objects at runtime and doing your dependency injection stuff, and then it kind of gives it to whichever components are necessary. I won't go into fine detail, but just consider that reflection is really difficult to manage. It's not really encouraged. Sometimes it you know, if you have to use it, whatever, but those are kind of the main points why Dagger 2 might be better. Now, the thing about coin encoding, they're going to be, probably you could get them running in like a day or two, whereas I believe it took me, it's not that it took me 2 months to get Dagger 2 to work, it's just to get it to work properly in multiple different applications. I basically needed to study Dagger for a couple of months, because one of the problems I ran into is when I started learning it, they hadn't quite figured out how to get it to work with activity and fragment. So there's this like fragment injector and activity injector thing that allow you to basically do almost constructor level dependency injection for those classes. And so I learned it, and then they added those things, so I had to relearn it, and it was just kind of a nightmare. So Dagger 2 is not easy. What it comes down to, if you want to use the best tool and you don't care so much about the fact that it's going to be hard to learn, use Dagger 2. If you want a quick tool and you don't care that it uses reflection, you don't care that it doesn't conform to the JSR 330 specification, which isn't necessarily a big deal. If you don't care about, and this thing, if you don't want to be able to look through it and pretty easily find errors, then yeah, use coin encoding. So anyways, I will stop rambling there, and let's move to something else. All right, what else have we got going on? What's going on? All right. Oh, that's a good one I could touch on. So this one will also be a little bit speculative in nature. I'm pretty good with coroutines at this point, but there's still more things I need to learn. So Arpan asks, should we learn RX Java or use Kotlin coroutines? Which one is better? And then there was a follow-up to that, which was for network. So as a bonus for network stuff. So let me just have some coffee here. So what I would like to show you is that let's how should I do this? Let's go here, not there, here. And we'll go to okay. So I'll explain why. You'll understand why I'm showing you this in a moment. So I've opened up Kotlin MVP Calculator in my browser, and I want you to notice that there are two branches to it. There's master, and then there's coroutine. So I'll first open up the master branch here. And maybe what should I show you? Let's show you a repository, I think. Actually, no, let's just do this. Sorry, it takes a moment to set up these examples. Okay, and then I'm going to go to Coroutine and open the same files. Yeah. Okay, so what I'm going to show you is, let's just quickly revisit the question. So the question is, should we learn RX or use Kotlin coroutines? Which one is better? So, so the first thing I would say is I am in the process of converting my RX Java implementations into Kotlin coroutines. Now you have to understand that I've worked with RX Java for almost 2 years now, and I am actually quite a big fan of RX Java. So this is not me playing favorites arbitrarily. What I would say to you is you're going to be able to do whatever you want to do in either. So that's the first bit of information I'd like to explain to you. To give you an example, one of the reasons why RX Java was cool is that, for example, when you're working with RX Java, it's bloody complicated, so don't worry if you don't really understand this. Oh, I'm looking at the wrong. Where's the RX one? Here we go. So when you're working with RX Java, you get this thing called a Composite Disposable. That name, don't worry, because it doesn't explain to you at all what it is. It's not a very good name. I understand what they're saying there, but you know, it's just needlessly technical. Composite Disposable. So this thing allows you to keep track of flows of data. So a flow of data could be from a presenter to the backend, which then talks to a cloud database. So the question you asked, what's best to use for like network stuff, for network I/O? So in RX Java, you would basically wrap all of those different operations in a composite disposable, or I just call this thing an event stream. And when you want to just tear down all of the event streams, you just call event stream.clear. So why I'm showing you that this was a feature of RxJava which I wasn't quite sure Kotlin could do. Sure enough, not long after working with Kotlin, I figured out that I could do basically the same thing with a job object. And then each new coroutine I create, I basically, where is it? When I create the coroutine, I pass it this basically parent job object. And then sure enough, when I want to tear down everything, I say job tracker.cancel. So it's basically fundamentally the same thing. When I'm working with RxJava, what I would do is in the backend, am I in the backend? More or less. In the backend, I would create observables. I kind of hide it here. Am I in the right thing? Is this the... I think I might be in the wrong... Oh, this is the coroutine. Why did it switch those around? That's so weird. Okay, there we go. Sorry, that was the coroutine thing. Okay, so when we're working with RxJava, we create data through these things called flowables or observables. So we have all, you see all this ugly boilerplate crap here. And this is how we would kind of return data from our backend service. So this thing could be like a retrofit REST adapter. We return the results from it, and then we compose it into observables. In coroutines, we just wrap this execute function in a suspend with the suspend keyword, which basically creates a coroutine out of it. And then now I can actually write my asynchronous code in basically a synchronous way. So it's pretty damn handy. And to me, it's easier to read. So I'm kind of going all over the place here, but what I'm really trying to say is, let's go back to here. So far, there hasn't been anything I can do in RxJava which I can't do in coroutines. Now, there might be something out there because RxJava has a lot of operators, but so far, I've been able to basically handle what I need to do with coroutines. If it is true that coroutines allow you to do what you need to do as good or better as RxJava, it makes sense to learn coroutines instead. Why? Because it's better to use a language feature than a third-party library. Now, why are coroutines frigging awesome? Because suspending functions are much better than threads. So I can't explain this to you because it's a little complicated, but just understand that whereas RxJava allows you to take a unit of work, so for example, a call to a backend service, and work with it on a background thread, suspending functions are different. Coroutines are special. You can do that in a different way that's kind of more efficient. I can't really explain the suspending thing without taking the time to really sit down and create a lesson plan for it. But basically, there's benefits to using... Just watch videos on coroutines and you'll start to understand it. So what I would say to you is... so you're asking me, should you learn RxJava or Kotlin coroutines? To be honest, at this point, if you plan on writing Kotlin code primarily, don't bother with RxJava. RxJava is great. I love it, but Coroutines appears to be a better solution, and it's not a third-party tool. It's a language feature, although it is experimental at this stage. So what I'm basically telling you is probably you should learn Coroutines, and that's coming from someone who quite likes RxJava, so that says a lot. Anyways, let's get back. Sorry, that was a very rambly answer, but the ramble is strong today. All right, what else have we got here? I can answer that pretty quickly. So, where am I here? So Cameron asks for an architecture components question. So how do you recommend informing the view that an API error has occurred? So not network related, but like invalid parameters, which hit the onResponse callback. So I'm going to answer this question in a general way. What I would suggest you do is in your architecture, I don't even need to show you network-based code to do this. In your architecture, whatever your backend is calling back to, so you might be calling back to a model, a view model. Whatever gets sent back to the view model, there's different ways to do this. I do it with presenters. That object should be capable of representing multiple different states. So this function right here, evaluate expression, would be equivalent to like saying login user. So it's equivalent to like a use case you're talking about. So what I do is this single method, let me open it up. Oops, what am I looking for? No, I'm looking for the base use case. So my backend always returns these result objects. These result objects end up back here, and then I just check their state. So in the event that, like, say a validation error occurred, I would just call back like normal, except I would have an object which is capable of representing any error state I want. So if I go to evaluation result, this is basically what it looks like. So you could customize it to whatever you want. So you could customize like, you could say, excuse me, you'd say like API error, network error, and you could mess around with it. This is a great feature of Kotlin, is using these sealed classes, but you could do this in a different way with Java. So, and this is where you're going to want to handle errors. So we're always returning one object, but this one sort of wrapper for our data is capable of representing different error states. And it can be specific if you want it to be. You can have it actually have a specific error message if you like. So anyways, I have a bad habit of coming in and like ruining my code, and then later on I'll try and compile it and I'll be like, what the hell, why isn't this thing working? And it's because I got busy messing around with it. Anyways, so hopefully, I believe that answered your question. Yeah, so in your callbacks, use some kind of result wrapper. That's what I call it. Result wrapper. So a result wrapper is just like, for example, this thing here. Where is it? Where is it? Where is it? Where is it? Use like a result wrapper, which is capable of representing different states. So maybe, what's an example? Like, maybe you have like well, I can show you how it works in this application actually. So this evaluate expression backend thing, it is kind of a use case, but we'll just call it a backend thing. it'll first validate an expression. If that validation fails, then it'll return an error result. Then it'll try and compute the expression if it's valid. And if it doesn't have luck doing that, then it'll also return an error. And then I have a validation result.error. And then I have a evaluation, then I have a calculation error. So what I'm trying to show you is that by using this result wrapper, you can basically handle errors at any point of the architecture, and it'll all call back to the same spot, and that's really handy. So hopefully that answers your question. Holy crap, so many questions today. Okay. Oh, so I scrolled down and I saw that Cameron already saw the result wrapper class, so that is exactly what I suggest you do. Lots of examples for it. Again, I will probably butcher your name. I apologize. I'm just going to call you Ned. Ned asks, is it possible for you to copy-paste answered questions to the saved streams descriptions? Your streams are very educational, and that would be helpful while watching not on live streams. The thing is, Ned, here's the situation. I would love to do that, but I just don't have time to sit down and rewatch the streams and basically write out exactly where the questions start. There's going to be a point, hopefully, where I can like hire someone to do that, exactly what you're talking about. And I understand exactly what you're saying. It's just, I just don't have, it takes me like an hour to sit down and watch the friggin' thing, and I don't have time to do that, and I just don't care enough to do it, to be perfectly honest. What I was kind of doing before is I was writing in as I was answering the questions when I answered it, but what I'm giving you people is I'm trying to give you information and answers and stuff like that, and all of this kind of pissy little upkeep, every stream I got to do this, and this, I got to prepare for it, I got to do the post editing. I don't have a lot of time to do that stuff, to be perfectly honest. So I still say if someone wanted to like volunteer to do that, then I definitely would help them out in some way, but I don't have time to do timestamps for my videos, basically, the live streams, in a nutshell. Eventually I will, when I can hire someone to do that, then I will do that. But for now, I can't afford to hire someone, and no one's really volunteered to do it. So, not going to happen for now. All right, so what have we got here? How can I combine networking, FCM, and observables in RxJava? All right, so I'm going to kind of quickly and vaguely answer your question here. So you're asking a question which is very broad, but I'll try and help you here out, Victor. So Victor asks, so how can I combine networking, FCM, which is Firebase Cloud Messaging, I think, Room, and with RxJava? How can I, if I were to rephrase this, how can a person compose multiple different sources, we'll say data sources, because that's ultimately what all of these things are. They're just data I/O devices. multiple different data sources using RxJava. What you need to do, so what I'm gonna, this is a huge, very broad question, so I can only answer it in kind of a roundabout way. The good news is this is exactly what RxJava is really designed for. What you're going to need to do is, what I would suggest, so you've got your different data sources. So let's say we have Firebase down here and Room down here and some other system service, and then we have like this repository object or a use case in between. What you'll need to do is you'll essentially have to have your front end calling back to like, or talking to like a use case or an interactor or like a repository. There's different ways to kind of do it. And then that backend thing will compose the various sort of sources. So it could be network, it could be device, it could be this, that, and the other, together with observables. So you're kind of asking, well, how do I do that? I can't answer simply because I would need to look at code and show you, but you're going to want to use RxJava operators like .merge, which takes like merges two data sources together. You just, in a nutshell, you're going to need to compose multiple different data sources together using RxJava. That's going to depend on what you're doing, so I can't exactly show you exactly what to do. But yeah, just architecturally speaking, you're going to want to do all of that shit in like a use case on the back end. Particularly if all of these different data sources are working on the same data model, then the front end should not have any idea about that crap. Anyways, since I don't really have any more details to work with, that's really the best answer I can give you, is you're going to need to use RxJava operators like merge, zip, flat map, etc. So you're going to need to basically like chain your event streams together, and which should be actually pretty easy. I don't know about Firebase Cloud Messaging, but Room allows you to return observables. Retrofit allows you to return observables, so that should be quite easy. The difficulty you'll have is actually getting them to merge together. That needs to happen on a back end, or I would suggest that. And then as far as how to actually do it, then we're getting into implementation, and I don't know exactly what you want to do, and I don't really have code I can show you to do that. But it'll look something like, where is it? Is this the RxJava one? No. It'll look something like this kind of code. So we've got a use case here, and it's going to talk to one data source, which actually isn't even an observable in this branch. It's going to talk to one data source, and then it's going to talk to another data source, and then it's going to flat map something, and yeah, that's basically all I can show you there. All right, I'm not going to do too much more. Let's see what else we got. I'll maybe do one more question. Hey, what's up, Darrell? Bonjour, monsieur. Ça va? Well, that was actually what I was, yeah, I'm just reading Darrell's comments. If it's at all possible, what was your name? If it's at all possible, Victor, you're going to want to switch to coroutines. I don't know why I selected that. And the reason why is that, so that annoying, so callbacks like RxJava style are basically called continuation passing style, CPS. So this is basically in a nutshell how you typically do asynchronous code on Java and Kotlin is you write it in CPS. CPS is a big fancy word for callbacks. So for example, let's go to the RxJava stuff. So this right here, this callback, is continuation passing style. Or when I go to the presenter, so I tell it to do something. Where is it? On evaluate click. The result calls back here in the RxJava implementation. Why coroutines are so friggin' cool is that I don't really need to work with callbacks anymore. Where would it be? Presenter. So this is why coroutines are so friggin' cool. So I run this same method, eval.execute, on just an expression. This is a calculator application if you're wondering. So this same method looks like this in RxJava, eventstream.add, eval.execute, observe on this thread, subscribe to this. Then we've got all these callbacks, one of which I don't even use. This same code written in coroutines friggin' looks like this. So I call that same method, eval.execute, just like I call it here. Same method. I say value result equals this. Then I just use a when matcher on the result. If it's this, do that. If it's an error, do this. Isn't that cool? Like it, and so, but here's the key point. So coroutines allows you to write asynchronous code in direct style. So direct style is different from continuation passing style because it doesn't have callbacks. This is direct style, and then this is continuation passing style. A continuation is like an object which gets passed in and blah, blah, blah. So why this is cool is it's a lot easier to handle asynchronous sources of data when you can just write it in direct style. You don't get that enormous, let me show you really quickly. Callback hell. So this isn't even isn't even Java here, but callback hell is when you have a whole bunch of different steps. So for example, something like you wanted to do, Victor. Sorry if that was super loud. So you want to be able to like compose network and like multiple different sources. If you want to do that in continuation passing style with callbacks, then you end up getting this staircase thing and it's really ugly. So coroutines basically totally eliminates this. They're friggin' awesome and I really suggest people check them out. Anyways, oops, I just opened Spotify by accident. Okay, maybe one more question. Suman is laughing that I have a PhD in dishwashing. That's actually totally true. I have my post-secondary education credentials consist of 3 classes in college. One of those was introductory Java, and since then I have not set foot on a university or college campus since like 2014. I teach myself. But I have worked in plenty of kitchens, so I do have a PhD in dishwashing. Huh. What else have we got? Oh! Dorel pointed something out here. Launch method. Darrell is mentioning that I have to pay attention to exceptions in the launch. Yeah, I was wondering about that. So this is one of the things I'm still trying to figure out with coroutines, is which coroutine builder to use. And what Darrell just mentioned, so Darrell's a good friend of mine and the best programmer I know, and he was just mentioning that I guess with the launch coroutine, if exceptions occur, then it's a fatal runtime exception, which would make the app crash. So that is one thing I'm trying to figure out. One of the things I was considering doing is looking into using actors with named channels for this particular, for the callbacks on different suspending coroutines, or different suspending functions. So yeah, still getting there. The basic, what I was running off of is launch is apparently like a coroutine builder for set and forget type coroutines, and then you would use async if you want a deferred callback. And so I'm still trying to figure out what exactly I want to do with this, but at the very least it kind of works. Anyways, I think I'm going to call it a day there. I'm pretty damn tired. And yeah, that's basically it. Thanks for watching. Hopefully you enjoyed that show. Tomorrow we'll be live coding at 10 a.m. UTC -7. And I'm basically just going to be working on Catalyst and just hammering out some... I'll probably work on the data layer and just kind of get started working on that stuff, because I don't actually know exactly what I'm going to do with the user interface, so that could be pretty boring. Anyways, thank you for watching, and I'll see some of you tomorrow and maybe some of you next week. Peace out.